Okay, hello everyone. Today we are going to learn the definition about the derivative. So first, let me ask you a question. Have you ever wondered how your car's speedometer works? Okay, so imagine you are driving a car. You glance at your speedometer and it tells you the speed at this exactly moment, right? Not the speed over a last few minutes. Okay, that will be similar as how the derivative work. Okay, so I will say the derivative is actually just means the instantaneously rate of change. Okay, so because we have the instant rate of change, it tells us the exact rate of change of a function. If you think the position as a function, then we have the same thing, right? Or we can call it a speed. Sometimes we say speed is the derivative of the position or the displacement. Okay, for function, we can say is a slope of the tangent line too. Okay, so why could we see this? Let's show you a graph. Okay, so if you have a xy coordinate function x and y, you have a graph kind of like this. Okay, think about this one is your function. Okay, if you have 2 points a and b, let's say maybe a b. Okay, so here is fa, here is fb. Okay, we have a second line with across these 2 points. Okay, of course you have the slope of the second line, which is fb minus fa divided by b over b minus a. Okay, that is the slope of the second line. But what is the slope of the tangent line? Okay, let's think about this point is very close to each other. So we have the graph looks like this. Okay, let's say this point is x, and then we have very tiny, this point is x plus h. Okay, the h is the difference between these 2 points. And this part, you also have some point, which is fx and fx plus h. Okay, to get the slope of this point, we have to take this. So if you have these 2 points are close enough until they are a same point, they become a same point, then what do you have for the slope? The slope formula become like this. Limit h go to 0, fx plus h minus fx divided by h, right? That is the tangent line slope, the tangent line slope. We also define this one as a derivative of the function. This is the limit definition for the derivative. Okay, the function derivative. Okay. Clearly, you can see that is also the instance rate of change, right? If this part, if this x value is not x, is the time, and this part is not the y, is the position, is the displacement, then this point is what? It's the velocity at this point, right? It's the velocity at this point. Okay, that's what you see on the speedometer. Okay. Okay, so let's try a question that how do we find out a function's derivative? Let's say if fx is x squared. Okay, how do we plug into this formula? We can say fx derivative is what? Is the limited h go to 0 fx plus h minus fx divided by h. So we can write, just plugging in this one, x plus h squared minus x squared divided by h. limited h go to 0, and then just expand this one, so you have x squared plus 2x plus h minus x squared divided by h, limited h go to 0, and this part x squared cancel out, right? Oh, sorry, I miss h here. Okay, square here. Okay, so you can see we have the common factor, which is h, right? So we get h times 2x minus h, sorry, plus 2x plus h divided by h, and this 2h cancel out. Excuse me. So when h tends to 0, the final answer should be what? Here 0, final answer should be 2x. Okay, so we can say for x equal to x squared, the derivative of this function is just 2x. Okay, so if you have a position, a displacement function, which is xt equal to t squared, what's your velocity function? It will be what? Following these steps, you finally will got is 2t. Is 2t. Okay, you can see this velocity is the derivative function of the x. Okay, that's a very short introduction for the derivative. So next time we are going to learn more application about it, especially for at some point, what's the particular derivative value of at some point. Okay, yeah, that's it. So we had to learn the incident rate of change, and similar to how the speed will tell you what's the speed at a given point, and what's the relation between those and the derivative and the function of a tangent line of the slope of the tangent line of a function. Okay, yeah, that's it for today. Thank you.